Let's go ahead and start this. So we're going to be talking about relative maximums and minimums. So they're similar to, well, let's define them first and then we'll talk about the other one. So a relative maximum or local maximum is the y value. So I want to emphasize that. It's the y value. So I'm looking for the y value. Okay? That is greater than all the nearby values, okay? And then a relative minimum or local minimum is the y value. Again, it's a y value, so I'm looking for the y values for my answers. That is less than all the nearby values. So what that means, if I look at my little graph here, see this point right here? It's not the highest point that's going to be on my graph because this arrow means that it keeps going up, right? So my graph keeps going up forever and ever and ever. So it's not necessarily the highest point on my graph. But in that area, the definition says in the area, right? So in the nearby values is what it says. And what I say is in this area here, it's the highest point. So relative means in the relative area or the relative, I guess area is really the only word I can think of. I know there's another word, but I can't really think of it. So in this general area right here, this is my highest point. So this is a relative maximum. Maximum. And my what it is, and I'm just gonna, I don't remember if the next screen is gonna go over where the points are on this or not. So we won't talk about that yet. And then this one again is not the lowest point on my graph, but in this area, it's a low point. And the other thing, so this is a relative minimum. The other thing I need to talk about when I'm talking about relative maximums and minimums is it needs to have part of the graph on both sides. It needs to have, see how it has a graph coming off this side and this side? So it has to have both sides in there. Okay. All right. We're going to talk about absolute maximum minimum when I get to a graph with an example, and we'll talk about absolute maximum minimums because some of the ones we're going to be looking at will be absolute maximums or minimums, and some of them will be relative maximum minimums. Right now, especially on the work today, the homework, I just call them max or mins, so you don't have to tell me if they're absolute or relative. I just want to know that you can tell me that it's a maximum or if it's a minimum and where it's located at. That's what I'm really want you guys to be able to get today. Are we okay with that? So if I go on to the next, same one. Okay, it's not the same one. So I'm going to come back here so we can talk about where my where it's actually located at. Yeah, I can tell that this is a maximum because it's the highest. It's a high, right? Max means high. Minimum means low. So if we think about that, maximums can be high points on my graph. Well, how do I write what my maximum is? So I'm going to say my maximum, I'm just going to abbreviate it to max so I don't have to write it out so much. My maximum is the y value, is the y value. So what's my y value? Oh, no wonder they didn't do it there because it's not exactly on the thing. So we can't actually tell you where the y value is. That's why they didn't choose to do it on this graph. So sorry, we'll go ahead and go to the next one page. And I look and it did, does that talk about it? Sorry. Okay, I'm going to zoom in on this box here so we can talk about this. So this is how we're going to describe or write our minimums and maximums. So here is my maximum right here, okay? And how we're going to write that, remember my maximum and both my minimum and my maximum are the y values. So I want to know my y value, and my y value is how high it is, which is at 2. So I have a maximum value of 2. Do you see this where it says it? Of 2, a maximum, relative maximum of 2, okay? So I have a maximum of 2. But the other part of the definition is saying where that's at. So I've got a y value at 2, but at 2, where's my x value? So I want to go to my x value first. So I'm going to go, my y value first and find out how high it is right here. And then I'm going to go to my y value, my x value. Oh my goodness, I'm getting my x and my y's confused. I'm so sorry. I'm going to go to my y value first and find out where it's at. And then I'm going to go to my x value, and that's going to become part of my definition of where it's at. And I'm going to say I have a maximum of 2 at x equals 2. So when x equals 2, I have a maximum at 2, is basically what it's saying. So if I go to my minimum, which is down here, my low part, remember that's my low part, and I have it here. I want to go to my y value first. So my y value is the horizontal value here, right here. And that's at -4. So I have a relative minimum at -4 right here. See, right? Okay. Please, if I'm saying something that's messed up, please let me know. Okay. And then I'm going to look at my x value. So my x value is here, which is 1. So then I have an x value at a minimum at -4 at x equals 1. Okay, so now we're going to try it without them having it written out for us. So they have an example here for us if we need to look at it. Okay, so I'm going to go to the other side over here. And they kind of gave us a fill in the blank form for this, so that's okay. So what I'm going to do is the first thing I'm going to do is I'm going to locate my minimums and maximums. Okay, and because I have different colors, I can do this. If you guys have pencil and pen or whatever, you can do it also. Just two different things. Or you can do a solid circle and a dashed circle for one for the other. But I'm going to use purple. I've been using purple for my maximum. Oops. Well, it doesn't matter. For my maximums. Okay. And I'm going to use pink for my minimums. So here's my minimum because it's the low one. Okay. So remember, I want my y value first. I want a maximum value of, it's my y value. The definition on the last page said it's my y value. So what's this y value right here? Well, how far up am I? I can just go ahead and count up to 1, 2, 3, 4, or I can go to the y axis and count up 1, 2, 3, 4. It doesn't matter, wherever you want to count up for. So I have a relative maximum of 4. And where's that 4 located at? Where's the x value for here? So if I drop a line or dotted line down from there, what's my x value here? Well, that is -2. And then we're going to look at our minimum, and I'm going to look at my y value. Luckily, it's right on the axis. That one makes it a little easier because then I just have to count. Well, what is my minimum? -2. That's my lowest point, my lowest relative point on my graph. And where's that located at? Well, if I go to the x-axis right here, that point on my x-axis is 0. Okay? Questions? Because you guys are going to try this now. Okay, so we're going to do one graph at a time. Oh, what happened? I think I need to do this one. We're going to do one graph at a time. And I want you to tell me the minimum and the maximum of this graph. So go ahead and put that in the chat box, please. And put it in the form. You don't have to say, you can say min. This is how I would type it in. I would say max. I'm just going to make one up. 3 at x equals -5. Okay, that's how I type it. And then I could do min at the same thing. Okay. Yes, Roberto, very good. Nice job. You are doing awesome, by the way. I want to tell you that. Okay, I forgot to stop the recording while we did this. I'm sorry, there'll be a big blank spot in there. So I'm going to circle my minimum because I only have a minimum. It's okay, right? Sure it is. It's the lowest point on my graph, and it's at -3 at x equals 1. Okay, that's it. And do I have a maximum? I have none. I'm just going to say none because they gave me a line there. So I'm going to write on there. Is there a maximum? No, there's not a maximum. So I do want to kind of talk about this. So remember the other graphs kind of went like this, right? And they had, so there would be a point here, a minimum here, and a maximum here. It's not really the minimum though, right? Because this arrow continues to go down. So it's not really the minimum. It's just a relative minimum. This one, this point right here is absolutely the lowest point on the graph, right? Because there's no arrows that are pointing down. So that's the lowest point on the graph. So instead of calling this a relative minimum, this is called the absolute minimum. Sorry, I always forget how to spell minimum. So because it's the absolute lowest point on the graph. The other ones, this is the lowest point relative to the area it's in, but this one is absolutely the lowest point on the graph. Do you see the difference between absolute and relative? They're still both minimums. It's just how we're defining them. This one, absolute, is lowest point on the graph. Relative is in this area, it's the lowest point on the graph, but it's not necessarily the lowest point on the graph. And I can have more than one minimum, and I can have more than one maximum. Just so you guys know, I can have several minimums and maximums, okay? So think about that. Let's go ahead and go to the next question, and I'll give you another minute or so to go ahead. So let's talk about this. So let's circle my maximums, okay? So remember I said I could have more than one maximum? Well, I have a maximum here, right? But I also have a maximum there. Is everyone okay with that? So I have two maximums here. Is it okay? Yeah, it's okay. Because in those areas, that's the highest point, Remember, our definition is in that area. So we have to think about in that area, that's the highest point. So let's talk about the minimum, because I think I have a couple answers in here from a couple different people that aren't quite right. So a couple of people are saying this, that that the minimums are like down here and here and here and here. But those are straight lines. Notice all the ones that let me let Mauricio in. All the ones that we have done so far have not been on straight line. They've been on some sort of hump, right? They've been at a point on a hump. So that's what a minimum or a maximum is here. It's the point on a hump, not on a straight line or a semi-straight line. So my minimum on this particular one is right here because it's the bottom of my hump. In that area, that's the lowest point. Yeah, I know that it's not the absolute minimum point because we have arrows at the end, right? There's arrows here and arrows here. And that means it's going to keep getting smaller, but because it's on those arrows, we don't know where the absolute lowest point is. It's at infinity somewhere. And I think that's what, that's what that is, negative infinity. Okay. Because we don't know where that is, we can't say and it's not on -2. I just want to point this out because these arrows, even though they're getting, even though it looks like it ends at -2, they're going to start getting wider and wider. So once it gets to negative infinity, it's going to be much wider than -2. It's just going super slow. Okay. So we don't know where these points down here are going to end up at. I don't know where those points are going to end up at. So I can't really call those minimums. But I do know where this point is. This point right here, I do know where it's at. I can call that a minimum. I can call it a relative minimum because in this area right here, that's the lowest point on my graph. In that area of the graph, that's the lowest part. Does that make sense? Those of you who put in answers? So I'm always looking for humps. And that's where my minimum and maximum are going to be. It won't be on the lines over here. Not over here. If it's on a line, it won't be a minimum or maximum. It's always going to be on a hump. So I can say that. So the minimum, let's say minimum and maximum will always be on a hump or bump or whatever you want to call it, right? It'll be on one of the bumps or the hills or the valleys. Ooh, that's even better. Let's call that be on a hill or valley. Okay, so it's on a hill or a valley. So that means if I'm going to write this out, it says minimum first. Please tell me I didn't write that in the wrong place. Oh, I did. I'm so sorry. I was not reading. I just assumed that maximum came first. Bad assumption, right? So my maximum is none, and my minimum is -3 at x equals 1. Wow. Okay. So it wants my minimum first. And so my minimum is 3 at x equals 0. Okay. And then my maximum, I have two different ones. Is it okay? Sure it is. I have 4 at x equals -1, and since it's the same height, I'm just going to put 1. I'm going to put them both there like that. 4 at x equals -1 and 1. Okay. Now on your homework, it's separate, so you'd have to enter it both times, and you'll see. We'll go and look at one of the homework problems, so you can see how to answer it in just a moment, because I want you guys to be able to answer them. Okay, let's try this again. So there we go. Go ahead and do that one. Okay, So on this particular one, I only have a high point. It's an absolute maximum because it's the highest point I have, but it's still there. It's still a maximum. I do not have any minimum, so on my minimum line, I'm just going to write none. And then on my maximum line, my high point is at 4, at x equals -2. Okay, nice job, Roberto. Okay, so one last problem, and then we're going to look at your homework and show you how to answer that. So my high, again, I'm going to circle in my purple, and then that's because I like purple and pink, by the way. And then my low, I'm going to circle in pink. And so my minimum, the top one is my minimum. I got to remember that. So my minimum is at -1 at x equals 1. And the maximum is at 1 at x equals -1. Whew, they just kind of switched the numbers around there. Okay, is that okay? Yes, it's okay if they do that. All right, and that's it. That's all it is to finding minimums and maximums. That is it. I find my heights, I find my y's, and then where it's at my x's, and that's it. Looking for the peaks and the valleys, the hills and the valleys, however you want to think about it. So I'm going to, now we're going to go to the homework, and I'm going to show you how to answer them correctly so you don't get them wrong. Does that make sense?